Hello everyone, welcome to the Simplified Studio. It's been a while since I have made my last video, but I hope that you haven't stopped your preparation. And in our last video, we have started chapter 2 from NOVAS GRE Math Bible book. And here we will start from problem 4 because till problem 3, we have solved all the problems in our till our last video. So let's start with our problem 4, which is of category hard. So here for problem 4, we are given that for any positive integer n, pi n represents the number of factors for n. And it includes 1 and n itself. And we are also given that both a and b are prime numbers. So let's assume that we have two prime numbers, a and b. Maybe they are 3 or 7. Let's start with the small prime numbers because that will make calculation easy. Now pi of a or pi of 3 should be the number of factors for 3. Now, if we try to figure out the factors for 3, is like 1 multiplied by 3. So the number of factors should be 2. And for pi of b, which is pi of 7, if we try to figure out the factors, is 1 multiplied by 7, 1 and 7. So the number of factors is also 2. So pi of a plus pi of b, the value should be 4. Now, let's try to look what we have for column B. We have pi of a multiplied by b, which is pi of 3 multiplied by 7, which is 21. Now, pi of 21 should be the number of factors for 21, including 1 and 21 itself. So if we try to derive the factors from 21, is 1 multiplied by 21, and also 3 multiplied by 7. So there are 4 factors. So pi of a multiplied by b is also 4. So we have the same value. So the answer for question 4 should be C, since we have the same value for column A and B. Now let's try to move on the question 5. Here we are given that delta of m is given as the product of m plus 4, m plus 5, m plus 6. So we are given delta m as product of m plus 4, m plus 5, and m plus 6. Now these are 3 consecutive numbers, and for any 3 consecutive numbers, we will find at least one number that is divided by 2 and at least one number that is divided by 3. You can take an example for 1, 2, 3, or 2, 3, 4, or 3, 4, 3, 4, 5, or 4, 5, 6, and so on. And here you'll find like there is one number that is divided by 2, there is one number that is divided by 3. Here there is at least one number that is divided by 3, at least one number that is divided by 2, but we have 2 numbers. Here we have at least one number divided by 3 and at least one number divided by 2. Here we have at least one number divided by 2 and at least one number divided by 3, but both are the same number. So it doesn't matter whether it is the same number or 2 separate numbers. For any 3 consecutive numbers, we will have one number that is divided by 2 and one number that is divided by 3, and they both can be the same numbers. Since there are numbers that is divided by 2 and that is divided by 3, the multiplication, the value of these should be divided by both 2 and 3 or both divided by 6. So here for the number 5 question, the answer should be C or 6, because we have to figure out like which of the following number must delta n must be divisible by. So let's move on the next problem, problem 6. Here we are given like x star is pi divided by x or pi over x, and we have to figure out the value of this one. So we have minus pi s star, and there is another star over. First we try to derive it. We assume that the inner portion here is the x. So we can, from this equation, we can write it down as pi by x or pi by minus pi over star. Now we'll consider this one as x, and we can figure out the value like pi divided by pi over x, and x here is minus pi. So that will lead to the value like pi divided by minus 1, which is like the minus pi. So the answer for the question 6 should be C or minus pi. Now let's move to the question 7. We are given that A star B star is such an operator that A star B can be written as A by B minus B by A. So here we can write it down as like 1 by m is like A and 1 by n is like B. So we can write it down as A by B, which is 1 by m divided by 1 by n minus B by A from here. So B is 1 by n and A is 1 by m. And if we try to simplify it, we can write it as n by m minus m by n, and also further simplify it by writing it as something like this, n square minus m square over m by n. Now let's try to simplify the right hand side. Here we have 1 by n star 1 by m, and 1 by n is our a and 1 by m is our b. So we can write it down as a by b, which is 1 by n over 1 by m minus 1 by m over 1 by n, and simplify it as, which can be written as m square minus n square over m by n. Now we have the value for column A and column B, and here we are also given another clue that m is greater than n. Since these two values have the same denominator, we can cross it out. And for the numerator part, we know that m is greater than n. So this term for column B should be larger than column A, because column B is m square minus n square. So larger value subtracting smaller value than the larger value. So column B is higher. So the answer for question 7 would be B. Now we move to the final question, question 8. The column B seems quite simple. Let's try to figure it out. 729 minus 102 is like 627 over 3. And if we divide 600 by 3 is 200, and if we divide 27 by 3 is 9. So 627 divided by 3 should be 209. This is the value for column B. Now let's try to figure out the value for column A. The number of multiples of 3 between 102 and 729. So we start from 102 and we end with 729, and we try to figure out how many numbers they are inclusive, including 102 and 729, that is divisible by 3. And that can also be figured out from the difference. So if we subtract 102 from 729, so the range here is 6 to 7, right? Because we have seen it from column B when we subtracted the numerator. So if there are 627 number, and if we try to figure out how many of them are divisible by 3, it is more likely that there should be 209 numbers that is divisible by 3. But since both we are starting from a number and we are ending with a number, and it mentioned about including both these numbers, and we also know that both these numbers are divided by 3, because if we take 34 and multiply it with 3, it should be equals to 102. And for 729, we can take like 240, like 729, we can write it down as something like 600 and 120 and 9. If we divide 600 is 200. If we divide it with 2, and if we divide 120 by 3, it should be 40. And if we divide 9 by 3 is 3. So 243 would be the value if we divide 729 by 3. Now we know that both these numbers are divisible by 3. And when we include both the starting term and the end term, we should add one more values here. So it's like if we try to figure out a simple problem, like if we try to figure out how many of numbers that is divisible by 1 from 2 to 4, right? So how can you figure it out? You know that 2 is divisible by 1, 4 is divisible by 1, and also there are two numbers, because 4 minus 2 is 2, and if we divide 1 with if we divide 2 with 1, it should be 2. And since both these numbers are divisible by 1 and they are both inclusive, so we need to add 1. Like there are 3 numbers between 2 to 4 that is divisible by 1, because you can figure it out by manually, like 2, 3, 4, they all are divided by 1. So with the similar strategy, we know that here we have 209 plus 1 terms or numbers that is divisible by 3. So the value for column A should be 210. And we know that the value of column B is 209. So column A is higher. So the answer for question 8 should be A. And with this, we are ended up with all the questions from this video. So in the next video, I hope I will come up with some new problems. And till then, be safe and take preparations. Thank you.